Alright, guys. Come on, squeeze in here.
Working on it.
Alright.
What's going on, fellas?
Good morning, good morning, good morning.
Waiting on the damn engineer.
Yes.
Alright, so those of you who don't know me, I'm Billy Gauze. I'm the engineer that designed these plans you got in your hand. I've been doing this 22 years. I've got over 1,000 installs with what you got in your hand, personally. I want to show you guys how to do this. So I'm going to go around the room. Tell me who you are and what you've been doing, how long you've been doing it, and then we'll go from there.
Dustin Bradley, owner of the company. I've been doing plumbing and septic work for 4 years.
D. I'm from Jamaica. I've been doing plumbing and septic for the past 17 years.
Daniel, I've been doing septic for 6 years.
Mario, I've been doing septic for a year and a half.
Kyle, I've been doing it for about 3 months.
Before, I've been doing it for like 2 years, 2+ years.
Bryson, I've been doing it for about 2 weeks.
So we got a pretty diverse range of knowledge and skill sets in here.
I would assume so.
Damn, you guys gonna stand there in this whole thing?
Yeah, we got this.
They got strong legs. They need to learn how to stand on. Don't lock your knees.
So who here knows how to read plans?
Depends on what you're referring to as reading plans.
Those plans right there.
Well, since we've been not doing it correctly, I'm going to go on a limb and say none of us know how to read plans.
Good, I agree with you. Okay. Totally agree.
Okay, so nobody knows how to read plans.
No.
So it's very, very important. Whatever you think you know, or you thought you knew yesterday, or the world according to Billy yesterday, you might as well go out and take a shit with that. It doesn't exist anymore. What you guys have been doing has been getting you by. Health department's been very, very lax. I did the same thing with them that I'm doing with you already. I put their ass on notice. They will be following these plans to the letter. The state of Florida put me here for a reason. They said this particular system has to be designed by an engineer. And the reason why is this particular system allows the performance of the system to have exceptions where conventional systems don't. Who here knows the difference between a conventional system, a performance-based system, and an aerobic treatment unit?
I don't.
You do?
No.
You? You?
Well, we know we have to take a shit outside.
Good.
Who here wants to build a career at this company?
I would.
And don't
I
be
would.
bashful. I'm serious. I mean, if you're going to college and you want to be a cop, just say I'm going to college and I want to be a cop. Because I sure as hell didn't think I was going to be an engineer. So if you want to build a business, and that's what we're doing here, we're building a business. It's no big secret. This guy's brand new doing this, right? So what we're looking at today is the future. And I'm not here to pep talk you with a bunch of bullshit. I'm just telling you. At the end of this day today, you will know everything that there is to know about this system. How much you remember, you're going to be taking in a lot of information. Every one of you will have my cell phone number when I leave here today. Every one of you will have unlimited access to the engineer that designed these plans when I leave here today. If you go out and you fuck something up and you don't tell anybody about it, that's on your ass. If you go out and before you fuck something up and say, Billy, this is what's up. Dustin, this is what's up. Then we can help you, right? I'm going to give you the tools to be the fucking baddest motherfucking septic guys there are out there, because I can tell you right now, out of all of them in town, nobody has unlimited access to an engineer that's going to train them personally. And I don't give a shit how long it takes or how many days it takes. If If I have to come my ass over here and go in the field with you, I will. I mean, there's nothing shameful about that, right? Because I want you to succeed. And what we've been doing up to this point is not the definition of success. So my suspicions were, after talking to him, was even he has shortcomings when it comes to doing this work and understanding why we're doing it. So who here in this room, if I told you that you're going to stand here and pick this thing up and put it down all day long, would appreciate that job?
None of us.
Nobody.
But if I told you, if you didn't do this, your mama was going to die in a car accident, who would do this?
All of us.
All of us.
Because you don't want mama to die in a car accident, right?
Right.
So that was a pretty morbid example or analogy of, I personally have always learned by understanding why I'm doing it. So I understand that you guys are probably like that as well, because you're mechanical guys, because of what you do. So if I tell you, you do it this way because I said so, if you can find a shortcut, you're going to take it. And any motherfucker in here that says he's not is a goddamn liar. Because I would.
Right.
But if you know why that's important to do it that way, then you won't be inclined to take a shortcut, right?
Right.
Now, one thing I will tell you right now, I ain't the greatest shit since sliced bread. I've been doing it a long time, and I am an engineer. State says I have to be here to design this for you to put it in. Every way that you're going to hear from me today is not the best way. It's a way. Understand? You guys get out there in the field and you see something that's a good idea or an idea, say something. You know, we may change it. You know what I mean? I live in a world that's on paper and in a computer, but I've been in your world a lot. So, let's start with the plans.
Here, I'll put these right here so you can draw them or whatever you need to do. Start blurring down the replans and make sure.
Anybody want a chair?
No, they don't.
I'll take one.
Here you go.
So, all this is an instruction manual, man. Basic set of instructions. You guys ever bought something and it came in a box, and when you dumped it out, it looked great in the store. When you dumped it out, you're like, I got 5 million fucking pieces of this thing here. And you got A goes with F and all that bullshit. And then after a while, you just start to kind of figure it out on your own. Well, unfortunately, we can't do that with this, but this is kind of like that. So you can't put something in if you don't know what goes in, right?
Right.
All right. So let's start up here with the notes and the calculations. That's on the first page. And if you don't, over here on the side right here, on the right-hand side of the drawing, tells you everything about the drawing pretty much. The address is on here that you're supposed to be at. So if you're supposed to be going to 1313 Mockingbird Lane, and them plans don't say 1313 Mockingbird Lane, then you got a fucking problem. From this day forward, you should never go to a job site or leave this property without a piece of this paper in your hand with a permit that goes with it. You will have a set of plans on that job at all times. Everybody will have a tape measure at all times. Because you can't do any part of this without a tape measure. All right. So, over here also, you've got the scale. Any of y'all know how to use the scale?
No.
All right. Well, that'll be part 2.
I was about to say, I have a scale ruler in here somewhere, I think.
So you got the date of these plans. If you call me up and you say, Billy, one of these things don't look like the other, and I say, okay, well, what date is on your plans? And the reason why I'm asking you that is because there are many revisions of these plans. It is not out of the realm of possibility, and I will say this to you twice, it is not out of the realm of possibility that somebody messed up and gave you the wrong plans. Not because Bradley gave you the wrong plans. I've seen them come from the health department with the wrong plans. So, very important. I'll ask you what that date is. If my date and your date don't match, then you got a bad set of plans. You go down here to this bottom, sheet 1 of 2. That'll also tell me what sheet you're looking at. So, when you go down to that second sheet, it says sheet 2 of 2. This is a basic plans class, okay, guys? Don't assume that everything on these plans, you might do 10 of them that are just like this. And it's great if you memorize your work. Makes you more efficient, right? But all of these aren't exactly the same. They will change from time to time. Sometimes I put the header at one end and another header at another end. And we're going to go into why I do that. For the most part, they'll all be like this. You guys have seen this 100 times, right? So, here's the thing. If you get up here and you got sheet 1 of 3 or 4, when we have these big ass deep lots, I got to put them on more than one sheet. Because I have to show the inspector at the health department what the overall lot looks like.
Chocolate salmon.
Sorry, guys. It's okay. Okay.
So you may have a big picture of the lot. Well, if all you get is that, and you're like, how the fuck am I supposed to see that? You'll have a smaller version of that that's blown up, zoomed in, so you can see it and read it. But anyway, if you see sheet 1 of 4, and all you got is sheet 1 and sheet 2, don't leave. Don't go do the job, because you don't have all the sheets. Follow me? Every one of these sheets will have a piece of information on it. All right, so that's the anatomy of a set of drawings. Every set of drawings you ever get, whether it's mine, somebody else's, another engineer, whatever, you're always going to have this information somewhere. It might not be here, it could be down here, but it'll be on them plans. All right, so right up here, let's start with note number 1, all the way to the top with a star on it. This drawing is specific purpose for on-site sewage and treatment disposal system. No other use is authorized or intended by the engineer. Basically, what that does is, if a contractor in another trade comes up on your job site, he says, hey man, let me see your plans. You tell him, okay, sure. But whatever you do, what you're going to do with these plans is no bueno for you, because it's not designed for you, it's designed for me. The reason why we do that is because nothing on this, even though there's dimensions on this house and there's dimensions to the side, nobody should be laying their shit out on your plans. Follow me? You do what you're supposed to do. Don't let anybody conflict you into or second guessing you about what you're supposed to be doing. If a grading guy or a landscape guy or a foundation guy comes and says, man, your shit's in the wrong place, whatever, call that guy right there, he'll settle it. These dimensions are on the side over here so that you guys have a good reference point for where the slab is in relation to where your drain field and your tanks need to go. So this drawing is only set up for you, nobody else. All right, all the construction components, means, and methods shall conform to the latest administrative code 64E-6. Who knows what that code is?
I don't.
You don't?
No.
All right. Everybody needs a copy of the 64E. 64E-6 is a very plainly written. It's not ye, thou, shall, and all that bullshit. It's boring as hell to read, but when you go take a shit, take it with you and just read it. It's interesting when you get into it, seriously, because it's an installer's Bible. It's all the codes, the rules. It tells you what setbacks are, tells you what you can and can't do. It's very, very easy to read. You guys need to be familiar with that, because it's just going to help you. And nobody can tell you anything. If an inspector comes up on your job site and they're starting to ding you for this and ding you for that, you'll be able to know what they're talking about. And if they're not right, I wouldn't say get in an argument with them.
Hey, you know what I mean? Sometimes
That's
you gotta
his job.
knock a bitch out.
But, you know what I'm saying? Don't be a pushover either. Or if you can fix it on the spot, fix it on the spot. You get what I'm saying? If you don't know what they're talking about, you can't fix it, right? So if you're as smart as they are, which ain't hard to do, because all they do is they use that 64E. That's it. Very, very simple. All right. So that just means everything in here conforms to that. That means these are a legal set of plans. The approved plan specifications and permit for this project specifically, which means this lot only. Any deviation shall be submitted to the engineering writing prior to the start of construction. So that's a very, very, very important piece of information. You can't deviate from these drawings unless you call me and then send me an email and then I answer you. If you do, you won't pass. I promise you. The sun will burn out before you get a final and you won't have a job. That's not a threat, that's just legit. You cannot deviate from these plans. Who here has been installing all these systems you guys have been putting in according to my plans?
I guess we haven't.
Right. So our job is to be smarter, better, faster, stronger than everybody else, right? And that's what we're going to be as a team today. Smarter, better, faster, stronger. Nobody can tell us shit, right? Because we got the plans and we know what we're looking at, right? Mr. Inspector, show me on my plans right here. These are approved by the health department when you get the permit. They go with that permit. You should never have a permit without a set of plans.
Unless it's conventional.
Unless it's conventional, but you still should have a set of plans even with conventional. You should have the site plan.
Yeah.
All right. So all this stuff under number 1, this is all about this system design. You can't be, this is all the ingredients to the cake. Follow me? This is why we're doing this stuff. All right, so based on the information that's provided by others in the OSTDS application data, treatment for this system is 300 gallons per day. Okay? That tells you below that how we figure that out. A 3-bedroom single family residence at 100 gallons per day per bedroom for total square footage. When you get this code, the first parts of this code you need to go to is what is required for a certain size house. And there's a table in there that shows you what tank you should be putting in, the whole 9 yards. Listen, man, I am telling you, this health department is very, very prone to mistakes. Very prone. And if you're not checking your stuff, all you're going to do is follow suit right down that rabbit hole. And it's going to cause rework, friction, grief, the whole 9 yards. So, the code says there's 100 gallons per day per bedroom. So, if we got a 4-bedroom house, how many gallons a day are we designing for?
100,
5 bedrooms.
500.
2 bedrooms.
200.
Just so you know, 200 is the minimum for any size. If you got a 1-bedroom apartment, you're designing for 200 gallons a day. That's the minimum. All right. The treatment unit. This tells you what kind of treatment unit you're putting in. This is pretty easy to read, right? I mean, it's pretty self-explanatory, right? It shall be the Whitewater DF50 rated for 500 gallons a day. Why do I put on there how much it's rated for? That's for you. If you got a set of plans, it's for this says 600, and it's only rated for 500, who you gonna call?
Did it.
And say what? Hey, dumbass, you got a 6-bedroom house and you called out a 500-gallon treatment unit. That doesn't work. And listen, it very, very well may be that you are the guy that finds that. We submit about 60 permits a month. That's a lot of shit to be designing. I mean, we run through these things like shit through a goose. And I'm telling you, we're not impervious to mistakes. We make them all the time. The health department don't even catch them. And as we get into the day, you're going to find out just exactly how complacent the health department is and has been. They're not our enemy, by the way, guys. They're people we work with. And when you become smarter and they know they can't try you, then their job gets easier and so does yours. All right. So based on the NSF 40 data, this is really kind of minutia. NSF 40 is the testing. Who here has ever heard of UL?
UL listing? Like on electronics?
Like on that
Oh yeah.
On these plugs, are UL listed on the computer? They're UL listed.
So UL is Underwriters Laboratories. That's the testing for the national, or for the United States. It says they've tested and approved it, and everybody else has. Well, NSF is the National Standards Foundation. Every treatment unit that's allowed in Florida has to have that approval on it. Every one of them. So in the afterlife, if you're not here any longer, or if we decide we're going to go to a different system, or if you get a set of plans from another engineer, because you guys do a lot of installs, they're not just mine. You get another set of plans from another engineer, and it's not NSF 40, it should say it on the plans. If it doesn't say that on the plans, then you need to ask questions. All right. This one down here on the bottom, TN and TP are not addressed. So, who knows what a TNT panel is? Okay. In Florida, TN stands for total nitrogen, TP stands for total phosphorus. In Florida, we have certain areas that are called BMAP areas.
Woo!
Somebody's big ass knocked the door open.
My bad.
So you want to say too?
No, I'm okay, honey.
You need a beanbag?
Oh, there you go. That's money.
Beanbag chair for you.
We'll
Put you right here, Sam. Put you
There
right
you
here.
go. I'll take that
Like you're riding in the boat.
in the boat.
You need to make boat noises too while you're going.
All right. In Florida, in Jacksonville specifically, we have certain areas that are called BMAPs. This is an important piece of information you need to understand. Because if you go out to do this job and it says TN is addressed and you don't have a TNT panel with you for your Norweco system, you need to call that guy up and say, hey boss, it's supposed to be a TNT job. You gave me the wrong panel. If you put the wrong panel in the wrong system, you have a problem. You got to pull it out. BMAP areas are drainage basins where nitrogen is a problem. Who here knows what nitrogen does to our groundwater? You guys ever heard of Blue Baby? Palsy? Cerebral palsy?
Yeah.
What comes out of your ass and out of the animal's ass has nitrogen in it, has nitrates. Nitrates are turned into nitrites. Nitrites are turned into nitrogen. Nitrogen's in fertilizer, you know, you put it on your grass and all that. That shit's really no bueno, it's bad. It does not ever go away. Who here has heard about the Terre Haute project? Terre Haute, Indiana. It's a city about the size of Jacksonville. They can't even use their fucking drinking water there. They have to pipe it like 900 miles away. Because they allowed a whole bunch of shitty septic systems, no pun intended, in Terre Haute, Indiana, and they didn't address nitrogen. In over 40 years, all those nitrites went into the aquifer. They never go away. It's like methyl ethyl bad shit, like radiation. So in Terre Haute, Indiana, they had all these babies that were coming up with cerebral palsy and what they call blue baby. And their birth defects. And there was an abnormally high amount of those, but they didn't ever have any chemicals there, no manufacturing, no industrial. And then the University of Indiana at Purdue figured out that they had nitrates in their aquifer. Now it's banned to even have a well. They had to go around and abandon every single well. Can you imagine if you had to go around Jacksonville and abandon every well? That's crazy. So, in Florida, they don't want that to happen. So in areas where we have a lot of groundwater or runoff that goes into the river, those are called BMAP areas. It's required that we treat nitrogen in those areas. There's a singular TNT system. Singular green tank you guys put in. The panel's different. It's called a TNT panel, and that stands for total nitrogen treatment. Very important. You have to have that if you're going to put it in there. And it'll say it right here.
So the tanks and all are just the same, it's just a control panel part.
Right. And what that does is that makes that aerator run differently, and it reintroduces nitrogen in there. In a septic tank, I don't know how much of this guy, you want to know. I mean, I could talk you into a coma with this. But in a septic tank, you got your solids, and then your liquids run into a treatment unit or a dosing tank, right? There's bugs in here. In a conventional system, everybody know what PTI is?
We just tore it all out yesterday. All
Yeah,
that stuff that we
yeah,
tore out
yeah.
yesterday was all PTI.
Alright, so if you have PTI or even if you have chambers, in a conventional system, all the treatment takes place in the ground. All the bugs live in here. This is an environment. If you ever dig one of these up and it looks black and all that stuff, but it's not slimy, that's the environment. So all this flows through here, it gets pumped into here, and then this consumes it. It's called CBOD. Carbonaceous, biocarbonaceous oxygen demand. So CBOD and TSS is total suspended solids. That's the little particles of what comes out of your ass and what goes down the drain from your washing your dishes that goes in here. Them bugs eat that. That's a big science project. The bugs that are in here and the bugs that are in here, they don't get along. They're cannibalistic. So to get better treatment, the best way to do is recirculate back to here if you can, so that you can keep diluting the effluent. Does that make sense? Like you treat it, you keep sending it back here. So let me give you a good example of this. When you wash your car, you dip your hand in that bucket all the time. Sometimes you put more soap in there, right? Because the bucket gets empty. If you put more water in there, you're gonna have less what?
So,
Exactly. So this is our wash bucket. We want to keep putting more water back in here so we have less soap, less bugs. These bugs and these bugs don't get along. So what happens in a system, if you go on vacation for years and years, or if you have a vacation home and Super Bowl party, all of a sudden you get a whole bunch of effluent going in here. These bugs, they die if they don't have nothing to eat, just like you, right? When you don't feed them, they die. So when they have that Super Bowl flush and all shit, my system's backing up. That's because there's no bugs in there to eat that. Follow me? And when they die, they leave something called biomat.
Yeah.
It's a slimy outside of it. It basically is like a big condom. You can't get nothing out of it around the pipes. In a treatment unit, we don't have that. So in a treatment unit, y'all know what a singular drain looks like. Basically, you got 3 sections. This is the septic tank. This goes in here, and this is an aeration chamber. If you could see what this thing does when that aerator's spinning, it creates a big ass whirlpool, goes all the way down to the bottom. That keeps all that mixed up. What that does is that overflows into here a little bit when it's mixing it, and that does what we're doing here. You understand? It's putting these two bugs together. Then you got your filter here. This is a settling basin, and there's also a discharge right here. Stuff will build up right here. This right here, because of that, will blow it back up and get it into that current, and it falls back down here to the bottom. You're constantly diluting it, putting water in your soap bucket. So what we have that goes out to the drain field is clean water. If you walk up to a PVTS, if you're doing maintenance, and we're going to get into that, ATU or a PVTS, and you smell shit, you got a problem with your system. Don't do your regular checks and haul ass because something's wrong with it. You go up to that drain field and the grass is missing in some patches, or if you think you can step back and look and you can see the drip lines, can't see the drip lines, but you can see where they would be, you got a problem. So everybody kind of understand now how that works?
yes, sir.
So if it smells like it smelled yesterday when you took that lid off there when you threw up, that's not
So
good.
what happens is when you have the nitrogen reduction system, this aerator stays on a little longer, and it cycles more frequently. So we're constantly reducing that nitrogen, because nitrogen still will go out into the drain field. Nitrogen is something, if I had a glass of water with, I don't know, 2 parts per millionth of nitrogen in it, we wouldn't be able to see it. You know, it's just dissolved in the water. But when you get enough of it, it goes down in the aquifer and it builds up and causes problems. Everybody kind of understand that now? So, this system shall be time dosed with a demand override. The timer in the control panel, who here has set one of these systems up? Like started it up.
Storage panel.
Like a new one.
maybe two of us, 2 or 3 of us.
So when you pull this panel out of the box and you mount it, you plug it in. Everybody seen one turned on before?
I think I did, yeah.
Okay. You set them up before, right? Have you set?
I did.
Have you set the timer up on them?
Yes, I did.
All right. And what do you normally set the timer for?
It depends on the type of system that there is.
Okay. So typically we want to set our run times for 30 minutes on for our aerators. TNT panels will be set differently. They have.
They're
Are they still-
they're preset in the Norway, because the only ones that have to be really set is the deltas.
So I was about to say that. Even the presets may not be correct. Do you get a manual with every one of those tanks still?
I don't, but I have a big stack of them in the house. I can get those.
They used to ship a manual with every single tank. You guys should have one of these manuals in your truck. So if you're going out to maintain this thing, if you got a lightning strike, you got to replace one or something, whatever the reason, you need to be able to reference that and reset that. They come factory set at 30 minutes.
Right.
So, demand override. That means that the float you got in that tank is very important where you set that float. Because if you pump too much effluent into the drain field, you're going to saturate it. Hydraulically overload it. You know what that means? It's going to be so wet that it next time comes on, it can't recover. So if your demand override float is fucked up, you're going to do more harm than good when you fix this thing. So it's very important. Demand override pumps down inches of water in the tank, right? That equates to gallons, right? Every gallon has so many inches, right? So let's just say 1 inch for this conversation. Let's say 1 inch is 100 gallons. If you set your demand override float at 4 inches, and it's a 300 gallon a day system, we got 300 gallons a day worth of drain field in there, right? Square footage wise. What's going to happen? 4 inches equals 100 gallons per inch. That's 400 gallons, right? So you're going to send a shot at one time, 400 gallons right out to your drain field. If there's somewhere, once the next hour that doses, if they have another demand override sequence, or if it's been raining like hell outside, like it has right now, the ground's going to be wet. It's not going to have a chance to rebound.
Sit on the bucket.
Oh, Lord. I'll have to be comforted again.
Hey, I didn't ask for nothing.
Get you a cushion for your birthday, bro.
It's not going to have a chance to recover, right?
Right.
It's not going to go down in the ground fast enough. Every time this system has a demand override sequence, it resets that timer. Follow what I'm saying?
Yes.
So if we have a demand override sequence, here's our dosing tank. You got an alarm float, right? You got a demand override float, right? Are y'all putting 3 or 4 floats in your tank?
True.
So this is your on-off float, right? So at this level, you're going to have on and off. At this level, you're going to have demand override. At this level, you're going to have alarm. Got me?
That depends on the type of system, yes.
Any system that you dose should be set up just like that. What systems have you set up that aren't like that?
There's a reverse of the white water is a reverse.
As far as the elevation of them, that may be true. But in any case, you got an alarm, a demand override, and on-off. So, whenever this float's working, this float shouldn't actually be working. The timer should be doing all the dosing. It should be activating the pump. If it gets up to here, that means this thing got filled up faster than the timer. The timer doesn't monitor it. It doesn't. It's a stupid machine. It doesn't have any cameras or anything in there to see that. The alarm float, the demand override float will kick on and it'll drain it all the way back down to the off, right? Till that float right there falls. Once that float falls, if that timer kept ticking and 5 minutes from now, it wanted to dose again, you'd overload the drain field, right? So it doesn't do that. The timer resets. Once that happens, the timer resets in the control panel. It will not dose again for another hour or in however frequent you have it set up to dose. The way these systems are designed is they're supposed to dose once an hour. You got 24 doses in a day. So these aren't set up to design to dose 4 times a day, right? That's the way you guys set up conventionals, right? 4 times a day?
Yes.
So these dose 24 times a day. All right. This basically tells you how that happens. I just explained that whole thing to you.
Yes, sir.
Tells you what happens after the demand override sequence, the timer resets. All right, system flow monitored through the drip controller. The drip controller is not going to tell you how much gallons has gone through there, but it will tell you how many times it's dosed that day. So if you go to the drip panel, there's a key sequence that you can hit, and you can get that from Drew.
Okay.
And it'll tell you if there's a number 10 there, it dosed 10 times already. You know, you don't know. If you're there at 9 o'clock in the morning, you don't know when a demand override happened or anything like that. That's an important piece of information. You understand what I'm saying? So if you keep in maintenance records like you should be, when this system gets started up, let's say you started up at 12 o'clock on September the 1st, 2018. Okay, and now it's September 30th, 2018. If you go out to that system because they have a failure or that's wet, blowing out, whatever it's doing, and it's like 1 o'clock, and you hit that dosing panel, you know that it got set up at 12 o'clock, right? So it already should have dosed how many times?
One time.
Doses once an hour, right? You go out there and you hit that button, and it tells you it dosed 5 times.
Something's wrong.
Something's wrong. All right. So it'll tell you how much flow is monitored, how much flow has gone through the system. So if you got a 300 gallon a day system, who's got a calculator? 300 gallons a day.
Here's one right there.
Oh, we got one of them.
300.
Yep.
You can see all one.
300 divided by 24. 12.5 gallons per dose, right?
Right.
That's not a lot of run time when you think about it, is it?
No.
You got a tank and you have an inch is basically 5 gallons or 6 gallons in a tank in real life. To get rid of 12.5 gallons on a tank that pumps 25 gallons a minute, the pump only runs what, a minute and a half, 2 minutes? So it doesn't run very long when it does come on. So it's not like it's running and running and running and running. So if you walk up to a system, who here knows you can stand on the riser lid and you can know whether the pump's running or not, even if the tank's full of water. That,
Vibration. Yeah.
right. You walk up to a system, first thing I always do if I go up to a system, even during routine maintenance or I'm training somebody, is I stand them on the lid, and if the pump's running, by the time we tell a joke, if that damn thing's still vibrating, you got a problem, right? Because it should only be running about 2 minutes max. That's not a long time. All right, so that's how you tell how much has gone through the drip controller. If that thing says 9, and you got 12.5 gallons per dose, it's 1 o'clock in the afternoon, you got 112 gallons of effluent that just went to your drain field in an hour. There's a problem. I'm not saying you guys got to remember all this stuff. I'm just trying to tell you why and how. You understand? It's not important. You're not going to do this math in the field, but it's just things to think about when you go out and troubleshoot these things. Because I assume everybody in here will be doing maintenance. Who here's ever done maintenance on one?
I've done a little bit.
Maintenance is pretty extensive. It's more than you think.
I have all the tools in that under DeVars, but if you want to show them that as well.
We may get into that. All right. So the dosing tank tells you exactly what dosing tank you're supposed to be putting in, right? That's the one you got to put in because it's on the plans. If you need to change it, what you gonna do?
Call Billy.
I can make that change on the fly. You go down to Hajoka or wherever the hell you get these things, Circle K, whatever, and they say, hey man, we don't have any 540 dosing tanks, but we do have this 500 gallon a day, DeVar special or whatever. Can you use that? Yeah, you can. You just have to call me and tell me so I can do a revision on the drawing, get it cleared. You can put it in. Because if the inspector goes out there, they will never ever find that up until Monday. As of this past Monday, you will not get passed if it's not on this plan and it's not in the ground like it is on that plan. So, contractor shall use only approved bonding compounds and sealed joints, mid seams, risers, lids of septic tanks, and treatment units. So, what do we do when we put PVC pipe together?
Glue. Primer it and we glue it.
Primer and glue. I've been out looking at your installs for about the past week or two. Maybe some of you seen me out there, maybe you haven't. Some of them have primer on them, some of them don't. Can anybody in here tell me why? Who's the boss out here?
Dusty.
Who's the boss in the field?
Myself and the Dusty.
Okay? So, whose responsibility is it to make sure that their guys are putting this stuff together right?
Same.
So, why would I go to one install and the whole entire installation, there's nothing but rain and shine hanging out of the joint? And then I go to another one and it looks like we killed a purple monster on the drain field, which is great. I love that. I love that.
I would just like you to specify on that one.
So
We will be using primer and glue on every
from
single
today
PVC
going forward,
joint.
every single one we get purple primer and blue glue.
So, I told you I was also going to tell you why every time I told you something today. So now I'm going to tell you why. There's this big misconception in the plumbing industry that rain or shine does not need primer. That is not only a misconception, but it is partly true. Rain or shine was designed for wet applications and emergency repairs. That's why they even developed that. That's why it's called rain or shine. It can be used underwater. It can be used in wet applications. Right or wrong?
Right.
If you read the data sheet on rain or shine, and I have it on my phone if you want me to go get it, it tells you you must use primer with this product. In emergency or field expedient situations, you do not have to use primer because it does have enough solvent in the glue that it will bond. But you're taking a chance. Everything we do out here, you're doing standing on your feet, right? You're not down in a hole. You're not hanging upside down under a bridge.
Sometimes. Hanging on the dream septic tank, yes.
Okay. But for the most part, everything you do here, you're on dry land. You're on your own 2 feet.
Good.
You can get to it. So I don't declare an emergency on that, do you?
No.
So let's use primer, guys. Better to be safe than sorry anyway. All right. So what are you using on your joints for penetrations, for risers and everything else?
What do you mean? Be more
The
specific.
sealant.
How are you sealing anything else that you put together?
So right now we are using the Infiltrator designed silicone, 100%.
Okay.
Infiltrator
And
brand.
The Infiltrator designed silicone, and I also use this seal spray.
Like Flex Seal, the rubber
I use the
spray.
Flex Seal spray
top of the-
on top of that.
On top of the,
So I am 200% seal.
So what is the type of riser you're using?
Infiltrator brand.
Infiltrator designed risers.
We don't use corrugated pipe.
Okay.
Corrugated pipe's laying out there because Dakota wanted it for his house, so I ordered it for him. That was it.
Okay. So, in those applications, that may or may not be adequate. I assume that it is because Infiltrator markets it as a sealant for this penetration.
That's what they require.
Right. So if you're using that, that's great. We need to make sure we put it on right and enough of it, obviously. I will say this to you about this. If you use any other kind of dosing tank or if you use any other kind of riser, and you may or may not encounter this, do you know what these things are made out of?
No.
Polyvinyl plastic?
They're made out of plastic. You know what kind of plastic? It's called HDPE. High density polyethylene. You know, it's real slick, easy to cut, shit like that. HDPE does not have any adhesive properties to it. In order to seal something, you have to have a bonding agent, right?
Right.
So the surface has to be able to accept the sealant. Infiltrator is probably using PVC as a riser because PVC obviously will melt and the bonding agent will bond to it. HDPE will not. You get a piece of HDPE pipe or you get a piece of that green tank out there, you put caulk on it or whatever, I promise you the next day you can come over and put your fingernail under it and peel it right up. It'll be smooth as a baby's ass on the back. So be careful of trying to glue HDPE. You can't do it.
So what should we use for our penetrations on the green tank for our aerator? For our wire for the aerator? How should we bond that? Because
They have knockouts on them.
Well, no, they're drill outs. They're not knockouts, they're drill outs.
They have marked spaces.
Yeah,
for
yeah.
that.
And then,
I mean, I would use seal tie connectors. You know what I'm talking about?
like male adapter, or like a male adapter with a nut on it.
Does everybody here know what a seal tie connector is? You ever seen this gray flexible tubing and you got a plastic connector?
Little nut on the backside. But is
Yeah,
that-
there's a star washer on
but
the
is
back,
that
a lock
Is
nut.
that watertight? Like they've been
Yeah, it's got a
fixing
gasket on it.
it? Okay, so the gasket will be what makes the seal.
They're made for outdoor boxes and everything. You know what I'm talking about. It's a plastic. It's just like a little PVC fitting with threaded on the end of it. It's got a lock washer, lock nut on the back. It's got a little rubber gasket
It's
on
a
it.
conduit MA.
Yeah.
Flex, it's called Flex MA.
Flex MA. There you go. So that's what I would use. And all you need is a little piece about that long, a whip hanging out. Run your pump wires up through that. Who wires these things from the tank to the...
We do.
So you run the conduit all the way to the box.
I run conduit all the way from the box straight to the house.
Yep.
All conduits.
For the aerator and for the pump,
The entire system.
the whole thing. Yeah, for all yeah.
So I would do that if I were you, but I'm not, so I don't care what you do. Just make sure it's sealed. That's your thing. I would think about putting a flexible piece on there. That way you can manipulate it wherever you need to or whatever. That's up to you. I'm sorry?
I do.
Yeah, okay, cool. All right. This is an SDI drain field. Wait, wait a minute. Did I miss anything? All your manhole covers all have gaskets on them, right?
No, sir.
They don't,
Except for the
sir.
aerator. The aerator's the only one that doesn't.
Good.
but in your dosing tank.
Yes, sir.
Okay. The one with the aerator on it, how deep does that get buried?
You never get buried, sir.
You know why?
Aerator needs air.
So that lid is vented. There's an airspace all the way around it. It has to have air get inside that tank. If you bury that thing, you're not even supposed to have it within, I think,
6 inches? Yeah, I think that's stick out 6
It
inches.
should be 6 inches above grade, sir.
so the ants will get in it and water and all that other bullshit. And water, these aerators are not waterproof, as crazy as that sounds. You get water on an aerator, it's done. $300. All right. SDI drain fields. That's a subsurface drip irrigation is what SDI means. This is a very, 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 very important piece of information right here. Your drip tubing shall be NetFM 08 WRAM 0.9-12. Now, I know you're going to think I'm crazy as hell. You're going to look at me like I got two heads.
You're correct on that one.
Me and this guy went out to Kingsley Lake and looked at a system that was put in and they had the wrong drip tube.
He got it from
Norweco.
Norweco. Still the wrong stuff. Because he didn't read the plans. He just ordered whatever Norweco sent him.
They put it in, and it's the wrong drip tube. So just because it comes in a Norweco box, comes in a Norweco tank, listen, man, whose responsibility is it to make sure you put in the right stuff?
Our responsibility.
If you're putting it in, it's your responsibility. I mean, it's as simple as saying, hey, I don't have the right stuff, right?
Yes, sir.
But if you put it in wrong, who's that on?
Us.
So let's talk about what this 08 WRAM .9-12 means, because it does mean something, and it's going to mean something to you. Everybody knows a drip tube has a tag on the end of it, right?
Yes, sir.
When you cut that off, what happens to the drip tube?
There was a tag.
Then how do you know what you
It's
got?
a foot shorter.
Good.
Then how do you know what you got?
You never know what you got.
Yes, you will,
Okay.
because of this right here.
Okay.
So this is how you know what you got. First of all, whenever I cut the end off the drip tube, I always take the zip tie and put it back in the drip tube somehow, even in the middle, whatever.
Yeah.
Like inside in the middle, because it unravels from the outside, right? So that way is you're sure to know what you have. And if an inspector walks up there, I'm going to tell you this for a fact. If an inspector comes on your job site and asks you to see what drip tube you're using and you don't have that tag, they can actually make you rip it out, even if you got the right stuff. There's a good chance that you can show them the plans and show them what you know, which I'm about to teach you right now, and then they'll let you go. I know in other counties, which you guys may or may not be going to other counties, Baker County, they won't fly. You gotta have that tag or you're ripping it out. So, this 08, that means 8/100ths of an inch in diameter. This WRAM, you don't really have to worry about that. You see that 0.9? That's 0.9 gallons per hour. So everybody's seen drip tube before, right?
Yes, sir. I think
Looks
so.
like this.
One every foot.
Should have one every 12 inches, right?
Yes.
So when we go out to lay out our drain field, we're going to measure in 6 inches, right? Or you can measure in an inch. I don't really care. But you're going to measure in. The best way to do this is a way. A way to do it, should I say. I always try to cut my drip tube right in between these two. That way, and I'll show you a quick and easy way. People always say, why don't you put dimensions on your plans? I say, why don't you read my plans and understand what you're doing, and then you won't need dimensions. Because these things get really busy really quick, these plans do. If you need 26 emitters, how long should your drip line be?
26 feet.
27 feet.
27 feet. Because
6 inch on both sides.
from this one to this one will be 27 feet long. But there will be 26 emitters, correct?
Yes, sir.
But if you cut that thing 27 feet and it's cut off right there, how many emitters do you have? You're one short.
Yes, sir.
If you cut too close, who here has cut too close to one of them and found out what's inside of it?
Going, son of a bitch!
So inside this drip tube, when they make this shit, it comes out of a mandrel. This thing inside is actually about this long. It's got a little hole in it.
Yeah.
Anybody seen what they look like?
Yes, sir. Looks like I do.
So that's basically like a screen. It's drip compensating. It takes a certain amount of pressure to make that thing piss out 0.9 gallons per hour. Now, I'm building this, so you guys need to start paying attention to this. If you cut this thing at 6 inches over here, then you know you're going to have enough if you make it 27 feet long.
Yes, sir.
Because you'll wind up with 6 inches on this end, 6 inches on the other end, you'll be good to go. So all you need is a tape measure to cut that long as it is. 0.9 gallons per hour. How the hell do we know we're getting 0.9 gallons an hour out of that thing? We have to be, because that's what the design was specified, right?
Yes, sir.
So if I have 300 gallons a day, and I'm dosing 24 times a day,
Yes, sir.
and I need 0.9 gallons per hour, that times 288 emitters ought to be 12.5 gallons an hour, right?
Yes, sir.
Everybody following along?
Yes, sir.
How do I know I'm getting that 0.9 and I'm not getting 0.7 or 1.2? First of all, the emitter will not let more than 0.9 out. I don't give a fuck. You throw it off a building. Take it to the bottom of the ocean. It will never let more than 0.9 out. But it will let less. So to ensure we have, so everybody says, well, why don't we just open the valve all the way up if no more than that can come out? Because the strength of the drip tube, it will be compromised. You can't have any more than 45 psi on this drip tube. If you do, you'll destroy it. You'll blow the connectors out of it. It'll prematurely wear out. When it prematurely wears out, anybody in here ever heard of something called scour?
No. Yes.
All right, so scour is an abrasion. So if I had a piece of sandpaper and I was rubbing it on this table, what am I doing? Scouring it, right?
Right.
Eventually there's going to be, if I do this long enough, there's going to be a void there, right? Because I'm going down into the wood. Scour occurs inside a pipe whenever you have too much velocity of the water going through it and that water's got shit in it. So, when we could talk about down here where we set our pump pressure, who here has set pump pressure before? We're going to talk about how to do that.
Yes, sir.
All right. So that 0.9 gallons per hour, do you see that dash 12?
Yes, sir.
Here's the important part. That means 12 inches on center.
Not going for it.
Every roll of drip tubes, I'm telling you, this is funny as shit. Because when we called Norweco, they were like,
Do
"Get
what?
the fuck out of here." And then they looked, and sure as shit, somebody put the wrong shit in the box. You need to make sure you have one of these every foot. The one they sent to the guy out there had one every 2 feet. That's half as many emitters, right?
So we're counting emitters. I was like, we do have the right amount of footage, but we don't have the right amount of emitters.
So if you cut my emitters in half, you cut my flow in half, right?
Yes, sir.
It won't work. So make sure you have 12 emitters. That's what that W12 stands for. If the inspector walks up on your job site, and they're hiring new inspectors too, by the way. I think there's 2 starting next week. We don't know where they came from. We don't care. But they're going to have a point to prove, right?
Yes,
New
sir.
guy on the job.
They want to make a name for
They want
themselves.
that badge, right? They come out there and you don't have your tag, and they say, "Let me see your tag." Or do you happen to have your tag? Don't tell them you don't have your tag. Just say, "I'm going to have to grab it for you." Let them mosey over there and forget about it. If they don't forget about it and they say, "Hey man, let me get that tag," you can say, "You know what, man? I think I left it at the shop. But look, I got these drawings right here." You show him a piece of that drip tube. Everybody's got a scrap piece laying in the truck, right? Or he can even go out there and look. I got 12 inches on center, and it's 8/100ths around of an inch. 8/100ths of an inch is just a little smaller than 3/4 of, or a little larger than 3/4 of an inch. The outside diameter of that is a little larger than 3/4 of an inch if you put a tape on. Now, it's going to shrink a little bit at the emitters because it gets stretched. But that's very important. All right. So at size for a peak loading rate, you guys probably, peak loading rate is how many gallons of effluent can I get in a square foot on that property? That's 0.8. You see over here it says with 6 SDI trenches and 3 laterals. So who here knows what a lateral is?
Outside.
So how many trenches do we have here?
6.
We got 6. All this stuff is to make you smarter. But if somebody comes up and asks you, you better be able to show them where it's at. Because if they got a bad set of plans and you don't, and they have the same address, 2 different dates, who's right? You are, because you got the latest dates. This is a trench. That's 4 trenches, right?
Right.
If I do it like this, and this goes back to my pump, how many trenches is that?
No trenches.
Still 4, right?
Yes, sir.
Because you got a header up here and a header down here, right? If I do this, how many trenches is that?
4.
How many?
4.
So if I do this, how many trenches is that?
4.
But how many laterals is it?
2.
Exactly. This is connected to that now.
Yes.
A lateral is one complete run. You follow me? How many laterals is this?
4.
Everybody understand that? Because they're not connected, they're individual. Sago, I did that like that. I had to do it like that to get my flow in that small amount of area. Sometimes to get my pressure that I need in this design to make the calculations work, I can't loop the ends. I can take up to a 40% reduction from drain field size. So let's just say regular drain field is 500 gallons per day for a 3-bedroom system. Actually, we'll go right here. 300 gallons per day. You see that? You see that slash 0.8 loading rate? You see that's 375 gallons, 375 square feet that I need, right? That's how many square feet of drain field that I need. All right, now you see that times 0.75?
Yes.
And you see the 25%?
Yes.
I'm making that drain field 25% smaller than it's supposed to be.
Yes.
I'm allowed to do that up to 40%. Only on PBTS. ATU is the only one I can do a maximum of 25%. So if you see delta up here, delta is good for what? Only ATU.
Good.
Delta will not do performance-based. The only one that will do performance-based is Norweco. If you see delta up here and you see a 40 down here, who you gonna call?
Billy,
You say what?
we have a problem.
Hey, dumbass.
We got a problem.
You designed this thing for an ATU and you took a 40% reduction. Can't do it. Why would we take a reduction anyway? Why wouldn't we just put in all of it?
Lot of factors.
Because ACH buys too small a lot.
I want to put 5 houses on it.
Too close to the well. Too close to the pond. Too
It-
close to something.
Right.
Standing water.
If I can, I always put it all in. If I can. No engineer likes to take a reduction because the more reduction I take, the more risk I take. They rent this stuff. They flush everything from the nose to the toes down the drain. They got 10 people living in a 3-bedroom house. They overload them anyway. All right. So, how many square feet of drain field do we have to put in now? After the 25%?
282.
282. All right. And now, how many did I design it for?
375.
Sorry?
375.
No, how many square feet did I design it for? It's on the end.
288.
288.
288.
You see where we're at, brother?
Yes, you're going to book.
Yeah, 288 square feet.
Right. You see where it says 288 provided, so okay? I have to demonstrate to the people who give us a permit that I designed this the right way. So that's why I have to put all this on here spelled out.
Which one? Bradley?
But it is important to you. But it is important to you to know what you're doing. Now, let's go back up to that little paragraph above that. So you see I got 6 trenches with 3 laterals, right? What is that right there?
6 inches, 2 laterals.
This is 3 laterals. Why?
Here's the equivalent.
Because they're looped, right?
Right.
So if I had a line here, what would that be?
6 inch. 6 laterals.
How many trenches would that be?
6.
How many laterals would it be?
6.
Exactly. So, you know how many trenches you're going to be putting in, right? And how many laterals you're going to be putting in, because I told you, right?
Right.
You need to be putting in 6 trenches, but you're going to be putting in 3 laterals. which means you don't do what?
You know,
You do loop them.
yeah,
loop.
you know, loop.
Right, exactly.
You don't put the head into it.
It's very important, guys, that you don't loop them where they're not supposed to be looped, and that you do loop them where they are supposed to be looped. And I'll tell you why. Because if I have a pump and I got a pipe that's 100 feet long, that pump has to have a certain amount of strength to push the water all the way down to that 100 feet, right?
Yes.
But any pump will push water out to the end of something 100 feet. One may piss out down here, the other one may shoot it all the way across the yard, right?
Yes.
So here's the challenge. I got to move it 100 feet. But down here, I got to have a certain figure. You understand? So if I got to have 100 psi and 10 gallons a minute, that's measured, right?
Yes.
So I got to calculate that, right?
Yes.
So if I take that same 100 feet and you do this, you gave me 100 feet of pipe, right?
Yes.
But is it 100 feet? There's something called friction loss. It's called head friction loss. So if I told you to haul ass as fast as you could run right now from this wall to this wall, you'd be pretty quick, right?
Yes.
Do you think your time would be the same if I told you, when you get right here where Dustin's at, I want you to turn?
And come back, yeah.
No.
Takes longer, right?
Yes.
Takes more effort, more energy, right?
Yes.
Same thing with water going through pipe. You get a certain amount of friction right here, a certain amount of resistance right here. So now we got two turns, right? So the pressure needs to be different to get this over here, right?
Yes.
Because I don't really get, I don't give a shit what direction I get this, as long as I get it. But here you're giving it to me down here in a straight shot.
Yeah.
So I don't have to work as hard. If you're giving it to me down here, we started down here, then I got to work harder. All that needs to be in my calculations, which is. So don't do this if there's this, because you're not going to get the same results. All right. This tells you how many emitters you need, right? So the number of emitters times the emitter spacing times 1 foot on center equals 2 square feet. Every one of these holes equals 2 square feet. So if you get in a bind and you lose your plans, I mean, you can really do this by yourself. So if you have 300 gallons per day, divided by 0.8 loading rate is 375 square feet. Divided by 0.75, because we're going to reduce it down 25%, right? That equals 282 square feet. Who in here can tell me how you would find out if you called Dustin and said, damn man, the plans blew out the window?
Stop smoking in the truck then.
Good.
How many square feet is his drain field supposed to be? He says 6 runs at 282. How would you figure that out?
I would have calculated or call Bill
282 divided by?
2.
2.
2.
Each one of these is 2 square feet. So I've got 2, 4, 6, 8 square feet right there, right?
That's it.
So if you got to have a 282 square foot drain field, how many emitters do you need?
144.
144.
288 is 144.
282 is actually 141.
141 here.
So
He's enough for 2 times another, yeah.
now you guys know why if you cut that drip tube short, it's no bueno. They're not going to pass you. If you put too much in, it's no bueno.
As crazy as that sounds. Looping the tails with emitters, no bueno.
Cannot do that.
That's why I have all that dummy pipe out there in that blue truck, now in the white truck. All that's dummy pipe because we don't want to add another emitter. That's the reason why I bought a whole 500-foot roll so we can cut 25-inch long pieces and stick those in the back. So we're not using emitters back there.
So let me tell you 2 reasons why. That was the first reason. The other reason has to do with the code. And we get into this in a minute, but I'm gonna go ahead and get you into it now.
Good.
All right. So we got a drain field, right, guys?
Yes, sir.
Everybody see that?
Yes, sir.
All right. So that is our drain field. So it has to have a 1.5 foot shoulder all the way around it. Actually, let me take this out. So from here to here, from the outside to your first emitter, to your first line, first trench, needs to be 1.5 feet. Everybody get that?
Yes, sir.
Got it? Down here, it has to be 1.5 feet. It's got to be all the way around it. Let me make this where it's not so exaggerated. So let's say we got all these emitters here, right? And right here, you got your last one. I'm going to make that 1.5 feet from my last emitter. All of your setbacks for your well, all of your setbacks to your property line, all of your setbacks to everything come from the emitter line, not from the top of your drain field. So if you got a tight site, or if I design them in there where you see them, where I got them all looking like this,
Yeah. Like that one.
that was a pretty mild one. You got some coming up that look like
The
stuffed
two
animals.
snells were tight.
right. So when you have those like that, your measurements are going to be pulled from that line, not from here. Now you see how much closer this line is to that end than it is to this end?
Yeah.
So if I have this as a emitter line, does that work?
No.
No bueno, right? Because we got, right now for what I just drew, we got 6 extra square feet of drain field in there that aren't in my calculations, right? Does that make sense now? So you see why we can't do that, right? Not only can we not do that for that reason, but then our drain field will get longer by 1.5 feet. Follow me?
Because that becomes the last emitter.
Exactly. And you have to stay how far away from that?
1.5.
Right. So if we don't have the room as it is, that ain't going to work. Follow what I'm saying? So that's why we do that. All right. So how many emitters do we need in a 288 square foot drain field?
24
And
by
how do you
6.
know that?
2 into 288.
How many square feet is each emitter?
Two square
You following along, brother?
Yeah.
All right. You, everybody?
Yes, sir.
Stop me at any time if you got questions. Don't let me just keep rambling. Y'all need a break? Am I boring you to death?
No. This is what we do, man. You know what we do.
I mean, does everybody understand what's going on?
Yes, sir.
All right. It's pretty easy so far, right? All right. So let's go below that. So is everybody clear about the emitters? How many square feet? Why we do what we do?
Yes,
What
sir.
they do? The setbacks? Why there's as many as there are? Now I was going to tell y'all about a cruel joke. I don't know if the inspectors would find it very funny. I had a guy from St. Johns County that called me up and said, "Man, my ass is wore out." I said, "Why?" "I had a big job out there. It had 900 emitters in it." He said, "My damn back hurts because I had to bend over and count every one of those emitters." I was like, "Did you dress yourself this morning for work? Why wouldn't you just do what?"
Measure the length.
If he measured that length, I told him how many emitters he had to have in every line, didn't I?
Yeah.
Right.
You take 288 and divide it by 6, that tells you how many lines you got, right?
Yeah.
Or how many emitters you have in every line. Forward or backwards, the math works, right?
Yes, sir.
10 minus 5 is 5, 5 plus 5 is 10, right?
Yes, sir.
Every day, all day. So I was just thinking, whatever. So I'll tell you another little thing here. So when we put these drain fields in, we have 7 inches of cover, right?
Right.
Yes, we can.
Hmm?
Yes, we can have.
What do you mean you can have?
7 or more. 7 or more is just saying.
7 is the minimum.
Okay.
Why do you
minimum is the
disagree with
minimum
that?
required.
No, 6 is required, but 7 is what we do.
6 is required and 7 is what you do.
Yes.
I'm glad you mentioned that. I was hoping somebody would point that out. So in a conventional drain field, the code says you have to have 6 inches of cover minimum.
Yes, sir.
How much maximum?
18 inches.
18 inches based on the type of chambers.
12. Florida state code says 12 inches.
Maximum.
Cannot have more than 12 inches over a drain field. Look it up. Florida Administrative Code. FAC 64E-6. Subpart B 6.008. You cannot have more than 12 inches of cover on a drain field. And I'll tell you why. Not that you really care, and I don't really either, but I'm here to teach you and make you better. So if somebody asks you a question, I've learned, even if you know something completely stupid as shit to know or insignificant, if somebody asks you that and you know the answer to it, chances are they ain't gonna fuck with you anymore, right?
Yeah.
So drain fields work 2 ways. They work through infiltration and they work through exfiltration. Okay? Infiltration means that they go down. People used to call that a perk test back in the day. You familiar?
Yes, sir. Yes, sir. Yes, sir.
All right. So we have to have sand in here. That's why we got to excavate sometimes. Because if you got something called spodek, who knows what spodek is?
Shit. Raggedy ass. Sir.
Spodek is hard pan. It's a limiting layer. It's compacted soil. It's organic. It's impervious. You know what impervious means, obviously. That means water won't go through it.
Yeah.
All right, so when we have to excavate, it's because there was something in there that won't perk. So we have to get it out down to where it's not that way anymore, and we have to put good stuff in there. So, infiltration. Drain fields use about 75-25. About 75% of a drain field infiltrates down into the ground, and it goes out through the sides. 25% of it gets evaporated, believe it or not. Took a thermal imagery camera first thing in the morning, you set it up over the top of a drain field, all of this over here would be hot as shit. Shit gets hot, literally, like it creates heat, which activates all the bugs, keeps all the bugs thriving. When something decomposes, it creates heat. Who here knows about baling hay?
Yeah. The hay gets hot.
If you bale green hay, this shit will explode. That's the truth.
Really?
Absolutely. Can't tell you how many hay barns and hay trailers. You ever been driving down the road, seen a hay trailer on fire?
Yeah.
That's because either some asshole threw a cigarette out, but about 90% of that is because they baled a green and it spontaneously combusted. Next time you cut your damn grass, just try it, seriously. If you do cut your grass, bag that shit up in some kind of bag, seal it up real tight, the grass clippings, and throw it up under the counter. Come back in about 2 hours and reach your hand in there. Shit'll be hot as hell. So, when things decompose, they create friction and heat. It's by a chemical reaction. So, when the sun comes out, it causes all that to evaporate. So, that's how a drain field works. You need you cannot have more than 12 inches of cover. That's why I was telling you that. Because it'll be too deep in the ground to promote exfiltration. There's a third reason for that. Third reason is, what did we talk about before? What causes blue baby?
Nitrogen.
Nitrogen in the water.
You stop answering questions. Nitrogen in the water. Where's the nitrogen getting the water from?
Shit.
Shit going in.
Out of your ass, right?
Right.
What do we put on our grass?
Shit.
Fertilizer.
Nitrogen, right? 10, 10, 10. It's nitrogen, phosphorus.
Yes.
All right.
Salt.
Flash.
So, plants, grass, generally only has a root of about 6 to 9 inches deep. If you went out and pulled out a big tall piece of grass out of the ground, the root's only going to be about 6 to 9 inches, right? It's not going to be 12.
No.
So, plants eat fertilizer, right? Which is nitrogen. So that's why we have to seed and hay and put, not only for stabilization to keep it from washing away, but we want the thickest grass on there we can. And we want the hardest to grow grass on there we can. That's why we used to specify, state used to make us specify St. Augustine. Because St. Augustine grass requires a lot of damn fertilizer to maintain in Florida, so it eats a lot. That's what we want over our drain field, because it's now taking up all the nitrogen residual in that drain field. Not all of it, but a big percentage of it. So if you have more than 12 inches of cover on there, you'll never get it. Right? That's why they don't allow more than 12 inches. Okay. So now we're back over here to our chambers, right? So we put 6 inches of cover on there because here's the top of our chamber, right? Now, I'm going to let you guys make a decision today. With drip irrigation, how many sides of that pipe are the emitters?
How many sides of the emitter?
So you got a round pipe, right? Let's do it like this. So you got a round pipe, right? It's like 3D. Pretty good, huh? Well, I worked on that shit for years.
1.5D, yes.
Alright, so we got an emitter right here, right?
Mm-hmm.
And also the other side.
On the other side of it, there will be another one.
So
Not
you're
there.
saying,
On the flip side.
so you're saying on the opposite side there's an emitter? No.
I don't think so.
No.
It's just one
There's
side.
only one.
Where's the
emitter.
piece of
On
drip?
the front side.
I thought I always like on this side.
Don't go all the way through, is that what you
No,
mean?
short piece.
No.
You mean the hole goes all the way through?
Grab one with at least 2 in it. We'll wait on him to come back.
I'll get something from this car in a minute.
We'll take a 2-minute break real quick.
I'm just gonna grab my phone.
Everybody can stretch your legs real quick.
What's up, brother?
I'm here, man.